Hey everybody, I hope that you are doing well. This is the last section in this chapter, and so we'll be testing. This is on function notation. So I told you if you tried the homework, I should have told you, if you tried the homework for 3.6 in my math lab, some of the problems may have been a little bit difficult and look like something that we haven't covered yet. That's because I've jumbled all the topics up in 3.6 and 3.7 to make them flow better. So I extended that due date till the same due date as section 3.7. So you should be fine doing both of them now after this lesson, 3.6 and 3.7's homework. Okay, so this is all about function notation. Okay, now let's talk a little bit about function notation. Function's just a fancy way to write down stuff that we've already been doing. So for instance, we've been studying equations that look like this, linear equations, right? Well, if we had the definition of a function last time, and it talked about inputs and outputs. So if we wanted to fancy this up some and use function notation, this is how we would write it, okay? So this is how it would look. Instead of a y, we use this fancy function notation that looks like this. A letter, then that's the name of the function, with parentheses and an x. This is telling us what we're going to plug in, equals. And then the other half is exactly the same, 3x plus 2. So you notice the only thing that looks different with this function notation is instead of saying y equals, we're saying f of x equals. So if we wanted to switch back and forth, we can. These mean the same thing. So f of x is the same thing as y. Now f of x gives us, that's how you read it, is f of x. This notation gives us a few things. It allows us to name our functions. So that is the name of the function. This is the function f. And then it allows us to think about things as inputs and outputs. So this thing in parentheses is the input. It's what we are putting in the function. And you see it pops up here, the x does again. So whenever I do plug in something, I think of this as the placeholder, these parentheses. I can put a value in and it will substitute in for any of the x's in the equation. Okay? So this is the input, this is the name. It's the same thing as 3x plus 2. Instead of saying y equals, we use some letter to give it a name, parentheses and x. And if you couldn't tell, they use f because it's the same letter function starts with. So for example, let me define you a function. F of x equals, well, we'll just use the same one, 3x plus 2. I'm allowed to plug anything I want to in here, which would be the same thing as just substituting in for the x. But this lets me do things like this. So I can say f of 5. Could we find f of 5? Well, you look at f of 5 and you're like, what are we doing? Well, what function are we plugging into? We're plugging into the function f. What was the function f? 3x plus 2. Now, I'm not going to plug in an x this time. 3 blank plus 2. What am I plugging in there? I'm plugging in a 5. So, because that's what I have in my little parentheses right here, that's what I'm going to put in the blank for x. I always suggest putting parentheses anywhere you're about to plug in things, but you don't have to, as long as you remember that that's 3 times whatever we plug in. So then we could just do some arithmetic, or you could use your calculator and type that all in at once. Your calculator will know order of operations, so 3 times 5 is 15, and 15 plus 2 is 17. So 5 plug in the function plug in a 5 equals 17. What's fun about this is I can plug in more than just numbers. I can plug in other variables too, like if I wanted to plug an m in. So now you know that I'm using the same function, f, that's the name, and I'm wanting to plug in an m. So this is my function f, 3 blank plus 2, 3 blank plus 2, and I am plugging in, what am I plugging in? I'm plugging in an m. Then you look to see if we can simplify this. 3 times m is just 3m. There's not anything you can do to simplify it, but I can plug in letters and all sort of stuff, okay? So what you're going to be asked to do on the test are a few simple things like this, like plugging in a 5 or plugging in a letter. But we can also ask you to plug in with a little bit larger functions like this one right here that I've defined for you. F of x is equal to negative 3x squared, x squared, plus 2x minus 5. And so then I can ask you to find certain things. So let's look at the first one, where we're going to take f and plug in a 1. So let's see. This will be equal to, so I like to just take the function and write it over again, but I'm going to leave blanks where there's x's. So minus 3 blank squared plus 2 blank minus 5. Is that exactly the same thing? The negative 3, the x is now a blank, the 2, the plus sign, the 2, the x is now a blank, the minus sign, the 5. So I have 2 x's in this one, but it does not change how I do this. I still have blanks. And then you can tell me, what am I plugging into those blanks? I am substituting in a 1. And once again, you could just literally type all of this in your calculator as you see it very carefully. Negative 3 parentheses 1 parentheses squared plus 2. Or we could do this just by hand. So order of operations tells me I have to do exponents first. What is 1 squared? And 1 squared is 1. Then I can do multiplications. So see, negative 3 times 1 is negative 3. 2 times 1 is 2. And I still have minus 5. Then I can subtract, or add and subtract. Negative 3 plus 2 is negative 1. And negative 1 minus 5 is negative 6. If any of the arithmetic confused you, just use a calculator. As long as you understand that when I give you this notation, I'm just telling you to plug a 1 in to this expression. So we plugged a 1 in. That's all that we are doing. So let's look at one more example of plugging in before we jump into some other connections. So let's see. So we're plugging into f again. Notice that's how I know we're plugging into f, and f is right here in this problem. So negative 3 blank squared plus 2 blank minus 5. So I've copied the function. I've left the x's as blanks because that's what I'm going to be substituting in a negative 2 for. So let's plop that negative 2 in there and be very careful with all of our work, our arithmetic. Okay, so I'm going to do the exponent first. Negative 2 squared is positive 4. Notice the squared only affected the negative inside the parentheses. That's why I carefully put parentheses. This is positive 4. It's not going to change this sign at all. So now I can do the multiplications. See, negative 3 times 4 is negative 12. And 2 times negative 2 is negative 4 minus 5. And then I just need to go about doing these addings and subtractions. Negative 12 plus negative 4 is negative 16. And minus 5. Not 16. Never mind. Okay, yeah, we're right. Sorry, I was thinking it was a 2. I don't know why. I see all the 2's and I got excited and thought it was a 2, but no, it's a 4. Okay, 16, and that should be minus 21. Awesome. There we go. Okay. Oh yeah, and we're done. Okay. Now, so this gives us this idea. So you remember the last time we had the discussion of inputs. We just described functions as inputs and outputs. I do not know why I wrote a D, but you know. Inputs and outputs. I can't spell. This is kind of where this comes from. This notation gives us inputs and outputs. If you look, we're putting our inputs in there and it's spitting out the outputs. Okay. Now remember, inputs were x values and outputs were the y values in everything we're doing. Okay. So if I have f of negative 2 equals negative 21, then I have this idea of inputs and outputs, or I could think of it as x's and y's. So this is where we're going to take this interval notation next, is into interpreting things as x's and y's, or inputs and outputs. So let me take you to the next page. Let's not even look at anything yet. Trying to cover all this up. Ignore the questions. Just look at what I have written in red here. Okay, what I have typed in red. So any number that goes in here as our input, that is the x value. Okay, and whatever number it equals, that is the y value. Okay, so this is our input and our output. So x, y. If we were thinking of what we've been doing, we've been graphing lines. And one way to graph was to plug in some x's, substitute in the x value, see the y value, and that makes an ordered pair or a point. Ordered pair. You could call it just a point, a coordinate. And remember, that makes an x, y coordinate. So we're going to use this understanding of these functions are just relating x's and y's from an xy point. Okay, so this gives us the ability to answer these types of questions. Now these will be on the test. So look at the first one. It says if g of 1 equals 5, write the corresponding ordered pair. So look, we know this is the x that goes inside there. We know this is the y. What point is this representing? What ordered pair? I'm not using the graph at all. I'm just using this. I have the ordered pair 1, 5. Okay, it's a really easy question. They love to put it on the test. Super duper easy. A lot of people miss it because they think there's some work to do there. They think it's too easy and panic, but I guess they sleep in class when I show them this example. But that's a pretty simple example. We give you all the numbers. We give you the x, we give you the y, and we would like for you to tell us what the ordered pair is. Well, obviously it's going to be 1, 5, x, y. Now the other things we like to do are give you one of the two and ask for the other one. So for what values does g of x equal 2? So remember, this is the y value, right? And this is the x value. I do not know the x value. I'm looking for this x value. So this is where we'll use the graph. Okay, so we're going to give you a graph on the test. If I go to a graph, my y value is 2. So let's go, remember this is the y-axis. Let's go to 2. Here's 2. Do you see any graph at this height? Oh, I see a point right here that would have a y value of 2. Oh, I also see a point right here at the same y value. So I see 2 points that would have y values of 2. Okay. What is this point? This is the point 2, 2. And what is this point? This is the point 4, 2. We already knew that it should have the y values. The question is asking, what are the x values? So what are the x values of these points? 2 and 4. So I can give you a graph and tell you the y value, say g of x equals 2. Hey, find the x values. So go to the graph, go to that y value on the y-axis, and trace it over to see if you find any points at that height of y equals 2. And I do. What are the x values? 2 and 4. Okay? So we can do the same thing, just backwards. We can do the same thing where we give you the x value, right? That's the x. What does it equal? I don't know. That's the y. Right? This all comes from this understanding right here that these things relate. All a function is doing is relating inputs and outputs, x's and y's. So can I find the value of g of 5? Okay, so earlier we had the formula, the function to plug into. Here we just have the graph to use. So if x is equal to 5, let's find x. These are counting by 2s, so I'm guessing x is equal to 5 is right there. That's 5, right? So let's look up and see if x equal to 5 crosses the graph anywhere. Oh, it does right there. Y'all see that? And this is the point, what? 5? 5? So if the x value is 5, what is the y value? What is the output going to be? It's going to be 5. So g of 5 is equal to 5. So that's all we're doing is relating x and y values by using this fancy notation, this function notation. And it all comes from this understanding of thinking of it as inputs and outputs, x's and y's. You have to have those phrases interchangeable in your head. Inputs are the same thing as domains, or the same thing as x's, outputs, the same thing as y values or range. Okay. Now, because these are related, x and y's, they make an ordered pair. And I can find these points on the graph of a function. Okay, so I could give you the y value, and you could find me the x values of any point at that y value. I could give you the x value, and you could find me the graph, the point, the y value of the point at anywhere on the graph that has that same x value. So you can find x's and y's. If you're given one, you can always find the other. Alright? So now that's actually the last bit of material before our test. Okay? So that's all that we have to cover. Let me remind you of some of the stuff that is on the test, kind of as a final rundown. So we did section 3.1 through section 3.7, except for we did cut out 3.5 is not in there. Okay, we'll catch 3.5 later in the semester. So remember, we started with 3.1 was graphing with a table. 3.2 was finding slope. If you go back and look at all the things we did in those are the things you need to know for the test. 3.3 was graphing with y equals mx plus b, slope-intercept form. 3.4, what was 3.4? Oh, that was writing equations. And remember, writing equations meant that we needed to do this formula, y minus y1 equals m parentheses x minus x1, that point slope formula. These are probably some of the harder ones on the test, in my opinion. I think everything else should be easy if you take your time. Let's say 3.4, skip 3.5, and 3.6 and 3.7 were both functions. Alright, so those are the topics on the test. This is usually the last page of the test. It's all this function stuff. Function, not a function, domain and range, and then what we did today. You do have to graph with a table and with slope-intercept. You'll have to find some slopes, and then you'll have to work writing some equations. So that's what the test will be like, okay? So, awesome. If you don't have any questions for me, I will see you later. So we will not have a video on our next class period. We'll take the test. So I will see you in 2 class periods. Awesome. Have a good day.